Okay, so here's the fourth question. A function y of t such that y of 0 is equal to 1 and y of 1 is equal to 3 e power minus 1 is a solution of the differential equation given. Okay, so here y of 0 is equal to 1 and y of 1 is equal to 3 e power minus 1 are initial function conditions. So let's write the differential equation given here. So that's d square y by dt square plus 2 dy by dt plus y is equal to 0. So we're supposed to find out what y of 2 is. So the next thing we do is write this in the operator function form, which would be d square y plus 2 dy plus y is equal to 0. So what I've done is written d by dt as capital D. Okay, so now let's take y common, d square plus 2d plus 1 y is equal to 0. So this, the equation that is there within the brackets is called auxiliary equation. So we take the auxiliary equation and equate it to 0. Okay, so that's the auxiliary equation. D square plus 2d plus 1 is equal to 0. This is a quadratic equation which can be written as a product of factors d plus 1 into d plus 1, which further gives us the values d equals minus 1 and minus 1. Now the roots are the same and the roots are real. So if you recall the general equation for such roots, general equation. Now first we are supposed to find out the particular solution. Okay, the particular solution. In order to find the particular solution, we first find the general equation solution. So that would be in the form e power ax into c1 plus c2x. Here c1 and c2 are constants. Okay, they correspond to the roots that we have over here. So e power ax into c1 plus c2x. Okay, and now let's call this equation 1. I think I can write it on the side over here, so please see. I'll write it here. Okay, so the general equation or the general solution, I'll put that down. The general solution y is equal to e power. Now what is a? A is the root that we have here, minus 1. Okay, so minus 1x times c1 plus c2x. We need to find out what are the values of c1 and c2. So that's our next step. And in order to do that, we take the help of the initial conditions given over here. Okay, so we start with y of 0 is equal to 1. Now when y of 0 equals 1, that means that y is equal to 1 and x equals 0. Now let's substitute that here and see what we get. Okay, so that would be 1 is equal to e power minus 1 times 0 is e power 0, which is again 1, and we get c1 plus c2 times 0. So here we directly get the value of c1. c1 equals 1. Okay, then next let's take the second condition given to us. Y of 1 is equal to 3 e power minus 1. So this says that y is equal to 3 e power minus 1 and x equals 1, the value that is there within the brackets here. Let's do the same thing. We substitute these values into the general solution. So that's 1 is equal to e power minus 1 c1. Oh, I'm sorry, this is 3 e power minus 1, right? So that's the value of y. c1 plus c2. Now we have the value of c1, 1. We can cancel out the exponential functions over here. So that's 3 is equal to c1 plus c2. 3 is equal to 1 plus c2, which gives us that c2 is equal to 2. So we have the values c1 and c2. Now when we substitute this into the general solution, it becomes particular solution. So let me just grab another piece of paper here, write that down. Okay, so I'll write that again. So the general solution is y is equal to, so we have e power minus x, e power minus x, c1 plus c2x. We have c1 equals 1, c2 equals 2, right? Okay, so let's substitute this into the formula above, equation above, and we get 1 plus 2x. So this is known as the particular solution. Okay. Alright, now the question says that we are supposed to find y of 2. So the value of x there is 2. So it says find y of 2. So here this is the value of x. Now let's substitute this x over here and see what we get. We get y is equal to e power minus 2 into 1 plus 2 times 2. So that's y equals e power minus 2 and 5. 5 e power minus 2. And 5 e power minus 2 is option B. That's your final answer.